Hey there, everybody. Thanks for joining us here at another session of Boca Code live. And we're bringing you a whole series of workshops and lectures and everything co-sponsored with our partners at South Florida Tech. They're really great. If you haven't checked them out, join, become a member, one of the best resources that there is. And if you don't know about Boca Code, join us at bocacode.com. We've got a really active Slack community, jobs posted and everything. So it's really great. Come join us there. But let's get started on what we're here for today, which is, if I can switch over, here we go. So today we're talking about three very fundamental things in programming. These are variables, functions, and arguments. And you don't need to know anything about coding to understand these and to play around and enjoy this lecture, hopefully. So for those of you who are new to coding or old to coding, one of my favorite places to play around is REPL. So the website is repl.it, and we'll be doing some coding there in a minute once we get through some basic stuff. So first, before I get into variables, I just want to make sure that everybody's on the same page. You're going to see in my code, you're going to see comments, and comments are just ignored by the program. They're just really for us, for the developers. And so you'll see comments. They usually start with a // they could be at the end of a line, they could be at the beginning of a line, and then also you can have blocks of comments with the /*, and then ending with */. So you could comment out whole blocks of code if you want to not execute the code, or if you want to, trying to turn on my video. There we go. Or if you want to comment a big block of code, or you want to add comments to your code, as we're going to see. Let's jump into it. So what is a variable? Okay, a variable is a named memory location, right? So here we have the name age, right? That's the name of our variable, and then we're assigning it a value in this case, which is 44, which is my age, right? So every variable will have a name, a value, and also a data type. And in JavaScript, there are a few fundamental or basic data types. One is an integer. So in this case, age is the name of the variable, 44 is the value, and the data type is integer. And we have primitive data types in JavaScript. These include BOOLEAN, which is kind of a new word to people who aren't programmers, right? And so in JavaScript, and that's, this lecture here, this talk here is really more general. It's not specific to JavaScript, but I am going to be showing JavaScript code. JavaScript is a dynamically typed language, meaning that you don't have to tell it that this variable awesome, that's the name of our variable here, is a Boolean. In some languages, you actually have to say Boolean awesome equals true, right? But in JavaScript, you could just say, hey, we're declaring a variable here. We don't have to say what kind of variable, because it's going to know what kind of variable based on what we have here. So in JavaScript and in most languages, the word true is kind of a reserved word. This means something very specific. Kind of like in mathematics, if the letter pi, the Greek letter pi, it means something very specific. Here, true means that it's like a switch. A Boolean is like a switch, like on or off, yes or no, true or false. And so the opposite of this is false, right? So the word false would be the opposite of true. And in programming, a lot of times we need to test logic, test whether things are true or false. And so we can use Booleans as advantages. So these are true or false, yes or no, 1 or 0, etc. The integer is another one we already mentioned, and these can be positive or negative whole numbers, right? Negative 365, positive 899, whatever, and they could be large and small. And then we have float. It's another type of number, but this one has a decimal. And I like to say that in most programming languages, our floating point numbers are actually irrational. And, you know, this is really getting into kind of the math nerd side of things, but in some languages, if you say like GPA equals 3.91, it will literally be 3.91, that rational number. But in a lot of languages, you have to be really careful because it will store this in a way where it's really like a number that's very close to 3.91. It could be 3.9100000001 or 3.990999999. So it's oftentimes these can be very close to, but not exact numbers. So we have to be really careful if we try comparing them. They oftentimes don't compare perfectly. Like two numbers that you set to 3.91 might not actually be equal, which is kind of confusing. The math nerds will probably love this because they're like, oh yes, no two values of one are the same. But anyway, so a floating point just in general is a number with a decimal. And then we have strings, and strings are just a list of characters, right? So here I'm setting first name equals Todd. That's me. A string could be a lot longer. It can have spaces, commas, you know, punctuation, special characters. We usually denote strings with quotes, either single quotes or double quotes. And if you need to put a quote character in there, you just have to like put a slash before it to escape it. Again, that's getting into a little more advanced stuff. So now here's a question, is what happens if I try adding something like a string to something like a number? Todd is plus 44. What happens? So let's actually jump out to, whoops, that's okay. Let's actually jump into a browser here. And this is REPL, and you can see I have some comments and everything and some variables assigned. And in REPL, we have this little, you know, playground here, and you can actually do this. REPL has a playground for a number of different languages. Here I'm using Node, which is a kind of a flavor of JavaScript. Really simple, really easy to use. JavaScript is very forgiving. You can have semicolons at the end of your lines, which some languages require. In JavaScript, they're like, put it there, don't put it there, whatever. I think that the code looks prettier without the semicolons. So literally, I code without semicolons for that reason. But anyway, and then you can actually run the code and have it and see your output over here on the right. So we're going to try that. We're going to use something here called console log, which actually will output the stuff in your console. And if you're writing code that's being used in the web, someone in their web browser, they can open up a console and actually see these messages. If you're actually coding like a program for your computer on Windows or on Mac or Linux, you can actually usually see this at the command line, depending. But here we're just running the code. We're writing the code on the left, running it on the right, so our console logs will appear there. So let's see what happens when we run this. I hit run, and it says Todd is 44. So what it's doing here, even though 44 here or age rather, is an integer, when we add it to a string, it converts it to a string, right? So if I were to say var, I don't know, aged equals 2, right? I've aged 2 years, and then I want to console log, you know, age plus aged. Because these are numbers now, it's going to treat them as numbers, and it's going to console log 44 plus 2, right, which is 46. And notice that this is, let me zoom in a little, make it a little easier on the video. Notice that here it's showing the number in orange, but here it's showing it in white like the rest of the string. With console log, I can also just give it a list of things to console log out, like console log out this string, Todd is, and this age, and then what we'll get is now we get this as a number here, right? Which is showing up in orange in REPL, just so you could see the difference. So anyway, that's just some quick basics of variables, of our primitive types of variables. So let's take a look. Whoa, sorry. Let's take a look at some other types of variables, and these are what we call compound data types. The first one is an array. And an array is basically just a collection or a list or a stack of a single type of variable. So let's say you're a teacher and you're coding something where you're keeping track of student grades, and you want to know all the grades, that Todd has gotten on his exams. You can have, or quizzes here. You could say, his grades equal 9, 3, 5, 8, 6, 4, right? And typically these are of a single data type. These are all numbers or integers. You can have an array of strings like Todd, Jen, Mariella, and that's how you do an array. That's a different type. Let's jump over into Chrome for a second and play with this in REPL. So let's not get ahead of ourselves too much here. So here we have an array. Let me get rid of these console logs here, because we don't care about those anymore. Just delete those. And here we have an array of numbers, and here we have an array of names. And let's console log x, right, and see what we get. And you can see it gives us a list of numbers, right? But in JavaScript and in most languages, there's very few exceptions to this. Arrays are what we call zero indexed, which means that if we want to grab this first element here, that's element 0. We don't start counting in programming with the number 1, we start counting with the number 0. So it's really 0, 1, 2, 3, 4, 5, right? But so if we wanted to grab, say, this number 5 here, that would be element 2. Even though your brain is saying, wait, it's the third thing in the list. It is, but the first one is number 0, number 1, number 2. So if we say console log the second element, we should get 5, right? So let's run this and see, and we get 5. If I say, give me element 0, we get the first one, which is 9, right? We could do the same with names, right? Names 0, we should get Todd, right? So this is a quick and dirty introduction to arrays. I just want to also show you this other property that arrays have, which is called length. So I can grab the length of an array, and what this is going to tell me is how many elements are in this names array, right? Which you can see visually is 3. If I run this, I get 3. However, what happens, remember up here, I defined this string of Todd, and I'd said a string is really an array of characters, right? This is really TODD. So if I also console log the length of first name, which is just Todd, right? You might think like, oh, well, that's shorter than Todd, Jen, Mariella. Todd, Jen, Mariella is much longer than Todd, but really what this is saying here is it's asking how many elements are in this array. The answer is 3. Then it's saying how long is the string first name. The answer is 4, right? My name is 4 characters long. We could also do something like how, grab the first name Todd out of this array and tell me the length, and we should also get 4. So I run this and we should get 4, 4. Okay. So that's one primitive or compound type, sorry, is arrays. The other kind that I want to talk about is an object. And these are a little bit more confusing. This is like kind of a little beyond beginner level stuff. I just want to introduce this, that JavaScript and many languages have this idea that variables can be built, can be constructed to be more complex. So here I've created a variable called person, where that person has a name, Todd, and has an age, 44. Right? So an object is a collection of key and value pairs. The first key being name, which the value of is Todd. The second key being age, the value of which is 44. Notice these are in curly brackets and separated with commas. And you don't need this comma here at the end. Some people put it, some people don't. There's reasons why I like it, which we can get into later. And then you can even have an array of objects, right? So here I'm creating something. This is kind of combining the idea of an array and an object and saying, well, let's create a variable named staff where we have Todd, who's a person, right, with a name and an age, and Susie. I didn't use anyone for my real staff because I didn't want to reveal anyone's age. You're welcome. So this fictional person named Susie, whose age is 38, and you can have as many of these as you want, and you can also add other parameters to that. So let's jump back into Ripple and let's get rid of these console logs here and uncomment out this, right? So now we have a person, name and age, and we can even do things like, you know, add an array here, grades, right? 99, 87, 93, 91. I usually got A's, right? We can even add, other things here like my LinkedIn, right? Which is linkedin.com/in/Todd right? And so now what can we do with an object like this? So Jen was worried that I was going to reveal her age, I guess. She just said in the comments. So let's console, if I could type, let's console log person and just see what's going to show up here first. And man, Ripple's very slow today. And you can see it console logs out the whole object in a similar formatting to the way we formatted it here. What's nice is they recognize this as a URL and actually make it clickable for whatever reason. But in JavaScript, we can actually refer to individual elements here. So like if I just want the person's name, I could say person.name and it'll just give me that, right? So now let's go in and play with this array here, and it's kind of the same thing where, if we try, well, first of all, now we have staff. So let's just console log staff here, which is these two people, and you can see it outputs this as an object. If we wanted to refer to, say, Susie's name, we would have to grab that second array element, right? So the first one is 0, the second one is 1, and then we would say .name, right? And this should return Susie, right? More likely what we would do with something like this, with an object like this, is maybe say console log name, and then we would console log person.name, and then we would say age, and I'm adding a little space here so that these line up, make things a little neater, person's age, and then let's just say URL and LinkedIn, right? So now I'm going to output this like nice little neat list. Whoops, I guess I spelled LinkedIn here with a capital I and here with a lowercase I. And so it didn't recognize that, and it came back as undefined. And that's another value that a variable can have, is undefined. So we can have things undefined means it literally is not defined. This variable LinkedIn with a lowercase I doesn't exist, right? It's only with a capital I. We can also define a variable with no with nothing to it, like let's say this one is going to be invisible if I call this undefined, and this one is going to be show me, and we're going to make this null, right? So there's null means, in mathematical, null is like, it's not 0, it means it doesn't have a value, right? 0 is a value. 0, there's a real value. Null means there is no value. So this is saying we have a variable named show me. Its value has not been set, or is set to be nothing. This one, invisible, says this is not defined, meaning if I try, let me comment out this and just console log. Sorry, I'm trying to type with my keyboard off to the side so I can have the microphone in front of me. That's why my typing is a little off. Forgive me for that. So if we try and console log this person, so okay, here it's actually showing the invisible, undefined. In a lot of cases though, if you undefine something, it will remove it from the collection. Here it's actually showing it. Okay, so let's go back, and I'm getting off track because I got a bug in my code. Let's go back and fix this to be LinkedIn in what we call camel case. So when we name variables, meant to mention this, when we name variables, we always start with a letter, and we can use either what's called camel case, where it has a hump. In other words, instead of saying like first name, that you can't have a space in a variable name. So we want to get rid of that space, but to make it more readable, we can capitalize that N. And in programming, you start to get used to reading capital letters as like new words. So you can have like customer first name like that, and you start to learn to read that as 3 different words, but it's the name of a variable. And naming variables like this, where it's very descriptive, is going to really help in your coding. If you just called this F, then somebody else looking at your code would have no idea what it was, including yourself. When you come back 2 weeks from now, you're going to be like, what the heck was F? The other way that we name variables is in snake case, where instead of putting a space, we put an underscore. So that's called snake case. This is called camel case. People have a lot of strong opinions about when you should use snake, and when you should use camel, and when you should use title, but that's beyond the scope of this lecture. But for now, we're just going to use camel case for just about everything. So as I did here with LinkedIn, so when I run this now, we get, it's saying my name, person's name, age, person's age, URL, person's LinkedIn, right? And there we go. So now I want to go on to the last part of this lecture, which is functions, okay? And functions with variables and functions, and then as we're going to get into arguments with functions as well. With these things, you can build just about anything in coding. So with a function, it's similar to a variable in that, here we say, in JavaScript, we just say this is a function, whereas in some languages, we actually have to define whether this function returns something, as we'll get into that. But basically in JavaScript, you just say, hey, I'm defining a function, I'm calling it do something, and then we have these open and close parentheses, which you'll see what these are for soon, and then open and close brackets. And inside the brackets is where your function is going to actually do something, right? So I'm calling this do something. Terrible name for a function. You want to say, as you'll see when we get going a little bit, you want to give them more descriptive names than this. But this is the basic structure of a function, the simplest structure. And in more advanced JavaScript, we can write these in some fancier, cooler ways, but I just want to keep things simple for now. And just it's function, the name of the function, open, close parentheses, and then you have curly brackets that put the body of your function together. Okay, so here you guys already know the console log. So I'm going to just create a function here called do something. That's just going to console log hello world. And hello world is always everyone's first ever program. The first time you program, you're supposed to get it to write hello world. So we didn't do that. We defined variables first, but when we write our first function, we'll have it console log hello world. So, oof, look at this. I have it console log hello. We need to change that. Very important, right? Some people put a comma here, some people don't. So this is now, let me get rid of these console logs. In fact, I can get rid of all of that and we'll just start fresh right there. So this is defining a function called hello world. And when I run it, nothing happens. Just like before, when I defined a variable, nothing happened until I actually use that variable as something. So here, I'm not using this function yet until I call it. And to call a function, all I have to do is give the name and these parentheses, right? Just like I have here, I just copy that there and I run, and now it says hello world. And this is a very stupid function because it does one line that, why would I write this whole function to just do something when it's just one line of code, right? Well, there's various reasons, as you're going to see. Now I could tell it to do something 4 times and it does that, right? But really functions oftentimes are not very useful until we get into arguments. So let's add the idea of arguments, right? So an argument is a parameter or list of parameters or variables that you pass into a function. And that's what those parentheses are at the end of the function name right here. This is where you put your arguments. And this could be just like in console log, we have the parentheses and then we pass things to it, right? Console log age, name, comma, this, comma, that, and it will console log all of those things, right? So here we want to give it, here we can define a list of arguments that get passed in, and then in our function we can use those arguments. So let's rewrite our do something method to take a message, call it message, and now we're going to want to call that with a string like hello. And then we could call it with a different string like my name is Inigo Montoya, right? Some of you know exactly what's coming on the next line. You killed my father. Prepare to die. If you don't know what this is from, shame on you. So now, what is this going to do? It's going to do exactly what we did before. Let me show you why. Boom. It says hello world 4 times because we're calling do something with a unique message each time, but we're not using that message here in the function. So we're just saying hello world. So how do we console log the message that's coming in? Well, we just tell it whatever message gets passed in, console log that message out. And we run that, and now we get 4 different messages. Now, Again, this is a silly function because all we're doing is we're replacing the function console log with the name do something. It's very silly. So let's actually let's get rid of all this, and let's actually create a useful function like this, okay? And this is a function that actually has something called a return. So this function has now 2 parameters, right, or 2 arguments, and it will actually return something. And most useful functions do these. They take arguments and they return something. So in this function, we're calling it calc tax, right, which is you're calculating the tax. So you give it a subtotal, you give it a tax rate, and it returns the tax. So let's call calc tax and give it a subtotal. Let's give it 57.23, and let's give it a tax rate 7%. Right? So now I'm going to run this. It's not going to do anything. I'll explain. Well, okay, it did do something, but that's because REPL's being very nice to me. What you really want to do is this is returning something, right? It's returning 4.0061. You actually want to store that. So we're going to call this tax amount, right? This is, so remember, whenever we declare a variable, we give it a value and then we set it to a name, right? We're setting a name to a value. So this is going to return a value, 4.0061. We're going to store it at a name called tax amount, okay? And then what do we want to do? We want to look at that. So console log, actually I have some console logs written down here. I'm just going to, let's call this my tax amount. And then it'll automatically be, you can ignore all the commented out stuff for now. And let's just look at this. We have our tax function. We're passing it these 2 values, which we know will be 4.0061. And then we're going to console log out tax, that amount, right? We run it, tax 4.0061. Perfect. Now, oftentimes let's say we're in some kind of e-commerce project, right? We don't want this hard coded, this number here, right? We actually want that's going to come from your shopping cart or whatever. And your tax rate is not going to be hard coded unless everyone's in the same county. This is going to come from some API or something, somewhere, some tax table or something, right? So let's actually set variables for those, right? And here I'm now saying my subtotal is 94.75. Okay, we can use the same value if we want, right there, right? And now, so if you notice, when we call this function with arguments, these arguments can be actual values or they can be variables, right? Which the variables will point to those actual values. It's the same thing like when we said, if you say console log 44 versus if you say console log age, if we have age set to 44, these 2 console logs will put out the same exact thing, right? 44. So we can either pass the argument in as, as the value itself, or we can pass it in as a variable name. So here I'm just setting the variables and then passing those variable names in. And when I run this, I should get the same tax rate. Okay. Then I want to create a total, right? So we've got our subtotal, $57. We've got our tax amount, $4. And now we want to create the total, which is we're going to add those together, right? So let's see what happens when we console log all of this out, right? So it says my subtotal is 57, my tax is 4, and my total is 61.23. And notice how this 6.0061 and 609999. This was that whole irrational thing I was saying. These numbers are equivalent, but not perfectly equivalent. So this is not what your receipt looks like at the store, right? How much is this person supposed to charge now, right? Do we charge them 6123, 6124, right? Your cashier will be confused if this is what they get. So we don't want to confuse our cashiers, right? So let's unconfuse our cashiers here. How do we unconfuse our cashiers? Well, this tax is a calculation that's coming out with some long number, and we want to make this prettier. So we're going to use something called toFixed, right? And a lot of people, I think, who don't know programming, they get really scared, they get really nervous. They think, oh my God, how does Todd remember all of these things? I could never remember all of those things, like toFixed. You don't, is the truth. Things you don't use every day, you don't remember. You have to look them up. And so, programmers spend a lot of their days Googling, how do I fix something to two digits in JavaScript, and then, toFixed, right. So this is just saying, take this number, fix it to 2 decimal places. So let me return this, and this isn't going to do exactly what we want, and I'll show you why. When we run this, boom, 4.01, perfect, beautiful, but it's a string. So when we add it to 5723, it converts 5723 to a string, and it adds them together, so you get 5723, 4.01. That's not what we want either, right? So after this toFixed turns this into a string, we want to convert it back to a number. Very easy in JavaScript. Just say turn that back into a number. Oops. Weirdness. Sorry, bear with me a sec. Number. Oh. Well, that's weird, isn't that? Why is that happening? So sorry, let me try running that again. So again, this is a perfect example. So we're getting, what is happening is it's adding this to 5724, right? Which gets stored in JavaScript as an irrational number. So this same thing where we do this number toFixed, we want to do to our total here, right? So we want to do the same thing to this total here, right? Sorry. We want to say toFixed to. Same way we did this, right? So we're adding these two numbers, we're chopping it down to 2 decimals, and then we're converting it back to a number. And boom, now we get something worthy of a receipt, right? Something worthy, to print out in an e-commerce application, okay? So that's, okay. So basically, just to recap, when we call functions, right? If it's a standalone function, meaning it doesn't return something, we can just call it with its name and pass optional arguments or parameters to it. If it has a return, then usually when we call the function, we set that return variable to a variable name, right? We name that whatever variable gets returned. And in more advanced lessons, you could see you don't have to return a single variable. You can return whole objects and things like that. You can get multiple variables back, but just to keep things simple, like this example, we get one variable back, we set it to a name that we can use. And that's it. That's with that, I'm going to wrap up. So remember, please, if you like this, like the video, subscribe. Also, go to bocacode.com, join our Slack group, and learn about more videos we have coming up. And I hope you found this useful, and have an awesome day.